Hello everyone. Today I'm going to discuss three-sum LeetCode question, and this is the ninth question in the 75 LeetCode questions list. So yeah, let's get started. So yeah, as usual, I'll follow these 8 steps, and yeah, I always say this is the most important part of the 8 steps where you actually try to figure out all the edge cases possible in the question. And yeah, okay, I'll start diving deep. So let's read the question first. It says, given an integer array nums, return all triplets such that I, j, k are not equal, and all of these numbers are actually equals to 0. Sorry, the question is really little bit cropped there, but what it means is like this finishes up as like nums of I plus nums of j plus. This is what they basically try to tell us. So okay, now the next thing we always do in each question is clarify what the input is. In this case, it's a vector of int, and here you can say that okay, it's always going to be equals to 3. So that means the input will never be this. It will always be 3 or big. So that's a good thing because we don't have to handle these edge cases then. Num size 10.5, 10.5. Okay, so this is a very good thing to read about the constraint so that you can say you don't have to take care of the edge cases like this. And yeah, that's the input, and the output they're asking is, if you see, the output they're asking is return the solution set, return all the triplets. And if you see in here, it looks like output is a vector. Now the thing is, this is the most important part of this question, I would say. It should not contain any duplicate. That means if you see -1, 0, and 1, this is the pair. Let's say quickly this -1, 0, 1, 2, -1, 1. Now one pair is this. Another pair can be one pair is this, this, and this. Another pair can be this, this, and this. But if you see, these are different numbers in different slots. But however, the triplet comes out to be 1, which is the same. So in this case, we only return -1, 0, 1 once. So this is the most important part. Now, if nothing sums up, then return an empty array and stuff like that. So, okay, now that we have that, next thing we want to do is do brute force solution. So brute force solution, what we can do is like, if we can figure out all possible triplet values, let's say -1, 0, 1, 2. I'm talking about brute force now. So if we can possibly figure out all possible triplets in this array, and then for each possible triplet we can say, okay, does this number exist or not? The sum of these triplet is equals to 0, and then just push that triplet to a vector which is result vector. Then yeah, we can do that. But one more thing catch here is like we need to figure out before we actually push the triplet into the result vector, we need to see if that triplet already exists. So for that, I think it will be a big of n cube algorithm in which first you would like to, it will take n cube just to figure out all triplets, because we'll be doing like first for int I equal to 0, I less than nums dot size, I plus plus, then we have to start for j equals to 0, j equals to I plus 1, then j less than nums dot size, j plus plus, then for k is equals to j plus 1, k less than nums dot size, k plus plus. So basically, yeah, and then here I, j, k will point to each unique triplet, and then here we have to decide if the sum equals to 0, and then push it to results vector. And if you see, this loop is run by n, this is n minus 1 time, this is n minus 2 times, and if you multiply these three, the time complexity will be turned out to be O(n) cube. So brute force will take some time, but yeah, it can get it done. And plus, on top of that, every time we figure out and push it to the vector, we need to iterate through result vector and figure out a mechanism to not push something in the result vector which is already there, because as mentioned in the question above, it should not contain duplicate triplets. So this is n-cube algorithm. There's another way we can do this question, which is efficient solution, I like to call. And if efficient solution, what we like to do is, let's pick up this array, minus 1, 0, 1, minus 1, 0, 1, 2, minus 1, minus 4. So let me explain this efficient solution with an example first. So first thing we do is sort this array. So it will become minus 1, 0, sorry, minus 1, minus 1, 0, 1. Oh, actually my bad. Let me just erase it. Once we sort it, it becomes minus 4, minus 1, minus 1, 0, 1, 2. Now sorting will take n log n. Let's say we use merge sort. It takes n log n. Now what we're going to do in this array is let's say, I think I need to bigger one, minus 1, minus 1. We start from here, I equals to 0, and then we'll take a left pointer and r pointer in the remaining array. And what we're going to do is say, all right, I equals 0. Now we want, if we can get a two-value sum of 4 in the remaining of the array, then that plus minus 4 will become 0, and we can just push that. Now we can keep going L and R and keep looking by 2 pointers if any possible combination occurs or not. So starting from minus 4, that's how we're going to do. Then next thing we are going to do is minus 1. Then we're going to go remaining of this loop. We'll take 2 pointers L, R, 1, and say if L plus nums of L plus nums of R is equals to 1, that means that's true. That means we found our number. So starting from, so because that L, R, and minus 1 will become 0, and we're going to push that to result. Now the edge case here is going to be every time we iterate through this vector, right? Like I equals to 0, I is equals to 1. Like after this array is sorted, we would like to move this forward if there is a common number ahead. So basically, if we evaluated all of these loops for minus 1, we don't want to do it again for minus 1. Just to avoid the case of if we do minus 1, this will always come. If we do minus 1, this will always come too. So, but we want to avoid that, so we'll start from here. Because anything that has minus 1, anything that's in, sorry, let me do this. So let's say we were here. Anything in this array with sum as 1 had already been considered in this minus 1. So that's why we will skip this part and go to 0 next time. We don't want to stay at minus 1 because anything in this array that has value of 1 is already been handled here. So that's why we'll move here and then we'll avoid this and then we go here and then keep going. So that way, the worst case scenario of algorithm is we're gonna run through this loop. Actually, let me take another code, another color. This loop will run n time, and plus every time worst case we would run for n minus 1 time, which is n square. So this is much more efficient than what we did above, which is n cube. And yeah, let me code out this question. So like I said, first thing we would like to do is sort nums dot begin comma nums dot end. And once you sort this out, I want to take a vector of int result. This is what we're going to return at the end. Now this is the fun part begins here. So we're gonna say for int I equals to 0, I less than nums dot size I plus plus. We'll say L is equals to I plus 1. Sorry. Oh, my bad. R equals to nums dot size minus 1. Yeah, we have L and R. Now what we're gonna do is while L is less than R. We don't want to do equals because suppose if we start going pointers everything, and if we come N and R both point here, that means we are pointing at the same number. We don't want to calculate it. So while L is less than R, first thing we're gonna do is say nums of L plus nums of R. Actually, yeah. What we have to also do is int to find is equals to minus of nums I. This is what we are looking for, the negative of nums I in the remaining of the array. Basically what I mean is like if I is at here, then we in the remaining of the array we are looking for 4, plus 4, because minus comes down to plus 4. So yeah, we're gonna say nums L plus nums R. If it's greater than to find, that means the total combination is bigger than what we are looking for. So we need to decrease this part. So because the array is sorted, so to decrease we need to move this pointer to the left. So we'll say R minus minus. Now else if we say nums of L plus nums of R is less than to find, that means this L plus R is less than 2 find. So basically we need to increase this L plus R, nums of L plus R. That means we want to increase this number. We want to move this pointer, and like this is the max already, and we want to add something bigger than left. So we're gonna say L plus plus, and else, this is the important case. If it's not equal, or if not greater, or if not smaller, then it's equals. And if it's equals, that's our edge case. Basically what we are saying is we were looking for this to find. It was neither equal to L plus R, it was not small, that means it's, sorry, it was not greater to L plus R, it's neither smaller than L plus R, it will be equal to L plus R. And once it's equal, what we'll do is result dot push back vector of int, and then just pass nums L. Are we looking for numbers or indexes? Let's say all the triplets. Okay, we are looking for numbers. So we are gonna say nums L, nums R, will return and nums of I. This will add, and once we do that, we will do L plus plus, R minus minus. So this is this case. Let's say 1, then minus 1. Let's say 0, 0, minus 1. Now, actually, yeah, this is case. Now let's say we are I is here, and now think about it. L comes here, R comes here. We'll say this sum is 1. Now, that's good. That's exactly what we wanted. Now, we want to avoid duplicates. So we want to move L. Actually, this is not the case, because once we sort, this will become like this, because the array is sorted, right? So yeah, think about it. Actually, let's do it this way. Minus 1. Yeah. So we are here, and the left is this, R is this. We need a sum of 1. This will have sum of 1. Now, this will have a left, and R will have sum of 1. Now we'll do push minus 1, 0, and 1 in the vector. Now if we move L and R both here, then 0 and 1 are again there, so we will again push minus 0 and 1. So we should not push this to the vector. So basically every time we find a number we're gonna move the left and right pointer to the next place where this number does not exist. So what I mean here is left num in this case becomes nums of L. R num become nums of R. Now while, and then actually I'm gonna erase this and I'm gonna say L plus plus R minus minus, and I'm gonna run a small loop while nums of L is equals to L num L plus plus, while nums of R is equals to R num. We'll do R minus minus, and then we'll go out of this loop. And then one last thing we have to do is, like, after we are out of this while loop, let's say here, we'll run again int current is equals to nums I, and we'll do if while nums I is equals to current will be like I plus plus. Let me think about it. Now I will automatically be incremented above, so I only want to leave I at the last value. So yeah, this will be like this, nums I plus 1 equals to current. So basically what I'm saying is, like, let's say minus 1 minus 1 minus 1 is the number, I is here. Now 0 1 2 3, I want to leave in I here, so that I don't actually here, so that I don't calculate again for minus 1. So when I do nums I plus, yeah, I want to leave I here so that the I is incremented by this I plus plus loop itself after the loop is executed. So I want to leave I at the last one. So I'll say current is nums I, while nums I is equals to current. Let's say this, well, nums I plus 1 is not is equals to current. Do this. So we'll keep moving it until the last part, but this might fail at I plus 1. Yeah, let me see what I'm missing here. Nums I, we took current. We want our pointer to be here so that I for loop can be incremented here. And I'm thinking, and I want to leave I here at the last one. Yeah, so this will be this. Now, while nums I plus 1 is equals to current I plus plus. So what we'll do is, like, I will come here, then we'll say nums I plus 1, this, which is this one, is it equal to current? It is. Then do s increase. Then we go here, we'll say nums I plus, is it equal to current? It is. Then we come here. Then we'll be like, all right, nums I plus 1, is it equal to current? It's not. Then I will just stop here, and then the incremental loop will be run of this one. And then I will go at 0, and things will start doing. So yeah, this code should work. And if you look at it algorithm wise, this is n times, this is worst case, n minus 1 time, this is big of 1, big of 1, big of 1, and yeah, of course at the end we have to return result vector, which is either empty or it can have all the data. And yeah, time complexity looks like to me is big of n square. So let me code this out for you guys. Let's quickly look through one of the submissions. So yeah, this is what we have to do. we also need to make sure that the next exists. That's what I was talking about there. So yeah, let's quickly code the question out, solution out, so that we can see what we did is good. Actually, let me share that first and show you what I did wrong. So the one edge case we forgot here is we are checking nums I plus 1, right? What if nums I plus 1 doesn't exist? So we can just say if this would be like while I plus 1 is less than nums dot size and this. That's it. That's the only condition we were missing. And let me quickly show you. That is exactly what was done here. Next is smaller than sys, so that we don't actually check anything out of bounds. And if next is smaller than this, it's not, then it means then there's nothing lying in the next. So even if I plus plus, it will fail because this condition will fail. So don't worry. Yeah. So let's start. We want to start by sorting nums. Once we sort that, what we want to do is, let me look through the code. We're gonna say we are returning this, so let's just take that. Result, and then we're gonna say start our loop. I less than nums dot size I plus plus, then we say now int L is equals to I plus 1, int R is equals to nums dot size minus 1, and then the one thing we want is int to find number, which is minus of nums I. Yeah, these are three things we want. Now what we'll start is while L is less than R, if nums L plus nums R, nums L plus nums R, if it's greater than, to find, my bad, that means we will do R minus minus, as if nums of L and nums of R is greater than to find, less than to find. Then we'll do L plus plus, else this is equal, so we'll say results dot push back vector of int, I'm forgetting the syntax, should be this, L nums, actually start with L, and let's say, so we are always pushing it in sorted order, nums I, L and R. Once it's pushed, we're gonna see int L num is equal to nums L, int R num equals to nums R, and let's see, yeah, while nums L is equals to L num, sorry, we can just say L plus plus, and this should be done shift tab. While nums R is equals to R num, will decrease R. And once this while loop R minus minus L plus plus results dot pushback R num L num is equals to num L plus. Alright, once this is done, we'll come out and we want int current is equals to nums I. Now what we're gonna do is while I plus 1 is less than nums dot size minus 1. Nums dot size, it's okay. Yeah. While I plus 1 is an index and nums I plus 1 is equals to current, just do I plus plus. This will always leave the I at the last index with the same number. So current, let's say current is minus 1 and next two are also minus 1. So it will come here, it will say, all right, next index exists. Yeah, it's not out of bounds. Then does the next index already equals to current? Yeah, it is. So it will like, all right, next index exists. It like, yeah, it does. And then it's like, does next index equals to the current value? It's not. Then yeah, we'll just leave it there and then let the I plus plus take care of it. And last thing we want to do, return result here. Now let me quickly check one thing, which is the syntax. Yeah, I think syntax is good. And solutions. So yeah, let's quickly run through it. We sorted it out. Let me see, sorted syntax is this. Yeah, sort is good. So yeah, we sorted out. It started iterating the loop. Left will always be I plus 1. This will toFind will always be negative. If toFind is greater than nums L plus R, that means we need to decrease that overall L plus R, which is R will do R minus minus because it's sorted array. Nums L plus R is less than toFind. That means we need to increase this, so L plus plus will increase this. Result of pushback will return if I and L are if it's the exact triplets that we want for sum of 0. We'll take L num R num. We're gonna move L plus N R until we find a unique one, and then once we come out of it, we'll say, all right, now it's time for current to move. Current will always keep moving if until I plus 1. Let's say we come at a point where I plus 1 is not less than this, then this will not run, and I will be pointing at the last index, and I plus plus will be done, and then it will not be nums dot size, so it will not be done. So yeah, this looks good to me. Let's run. Runtime error. Okay, what's the runtime error? Something overflowed. Undefined overflowed. Let's see what this error is. Let's see how's the difference. Return result, yeah. I plus plus, left is I plus 1, R is nums dot size minus 1, target is minus 1 num size, this is good, y less than R, nums L plus R is greater than target, R minus minus, nums L plus R is less than toFind, L plus plus or push. L plus plus R minus 1. All right. Every time we increase and decrease this, that's it. One more issue that came here is this. While L should be this. Yeah, my bad. And R is greater than 0. So the issue here is, I think we increased L at the end, which we shouldn't, and R, which we shouldn't either. So let's see. Yeah, it works. That was the issue. Same issue that we felt here. So L, basically what issue that I was facing here is in all these conditions is like whenever L and R, or let's say I, we are moving, we should make sure we are never going out of bounds. Because apparently it looks like here we are making R less than 0 and then that. So that's one thing to look into. And yeah, 96 ms beats 85%. Memory is pretty good. This question looks good. Sometimes decreasing the line count makes the memory say this is 64, 85. Submit one more time. 68, 86. Yeah, looks good. So thank you, everyone. Do remember that every time you every time you increase or decrease the counters, you need to make sure that they are not out of bounds. But yeah, sounds good. And let me know if you have any questions and comments. Thank you.